Hello everyone, in this lesson we'll be talking about trigonometric functions on a right triangle. Recall that in the unit circle, if you had a unit triangle, the hypotenuse was 1. So then sine of theta was y, cosine of theta was x, and tangent of theta was y over x, and cosine squared theta plus sine squared theta was equal to 1. We can extend this to larger or smaller circles with right triangle hypotenuse not equal to 1. For example, in this case, we have this black triangle, which was a form of a large circle with hypotenuse c, and that's not the same as the red triangle with a hypotenuse of 1. In the diagram, the triangle has sides ABC, C is the hypotenuse, then by similar triangles, y over 1 is equal to b over c, just by the ratio, the relationship between the sides. The ratio y to 1 is equal to b over c, and x over 1 is equal to a over c, y over x is equal to b over a. Thus we know, if we know something about the sine, the cosine, and tangent of theta, then we can use it for any right triangle. That means we can extend it to any right triangle. So let's look at an example real quick. What is the sine and cosine and tangent, cosecant, secant, and cotangent in the following diagram? The idea here is that we must find the value of a, and we can use the Pythagorean theorem to do this. Let's do it. A squared plus 2 squared equals 5 squared. That means a squared plus 4 is equal to 25. So a squared be equal to 25 minus 4, which will be equal to 21. Means a will be equal to plus or minus square root of 21. But the sign depends on the context. In this context, we need a positive value for a, so we choose root 21, positive root 21. Now let us look at the sine. Sine of theta will be the opposite over a hypotenuse. So sine of theta will be 2 over 5. Cosine of theta will be adjacent over hypotenuse, and we know that a was root 21 over 5. The tangent of theta is the opposite over adjacent, which is 2 over a, so that's 2 over radical 21. But we want to rationalize this to have a non-radical in the denominator. So we have to multiply by radical 21 over radical 21. That will give you 2 radical 21 over 21. Now let us look at the reciprocal identities. For sine, it's cosecant, so cosecant theta will be 1 over sine theta, which is 1 over 2 over 5, which is 5 over 2. Secant theta is the reciprocal of cosine. It's going to be 5 over radical 21. And if you rationalize that, radical 21 over radical 21, we get 5 radical 21 over 21. Then the cotangent theta will be the reciprocal of 2 over 20 radical 21. That's going to be radical 21 over 2. And we're done. So we found all 6 trig identities there. Let's look at another example. What if theta was equal to pi over 4? So theta is equal to pi over 4. So we want to find the sine of theta, the 6 trig identities of pi over 4. So that would be sine pi over 4, cosine pi over 4, tangent pi over 4, cosecant pi over 4, and so on. The idea is that if theta is equal to pi over 4, then x is equal to y. So we can label sides AA. So whatever letter one gets, the other one must get. And the hypotenuse is c. From the diagram and using the Pythagorean, a squared plus a squared is equal to c squared. That means 2a squared is equal to c squared. So if you take the square root of both sides, we have square root of 2a squared is equal to square root of c squared, which is c. So c would be equal to a radical 2. Now I want to find the sine of pi over 4. And we know that C was a root 2 opposite over hypotenuse. That's going to be a over a radical 2. So it's going to be 1 over radical 2. If we rationalize this by root 2 over root 2, we get root 2 over 2. Okay, so about the cosine of pi over 4. Again, a cosine adjacent over hypotenuse, that's a over c, that's a over a root 2, which we already found was going to be a root 2 over 2. Then the tangent, pi over 4, is going to be opposite over adjacent, that's going to be a over a, equal to 1. Now let's find the reciprocal identities. Cosecant, pi over 4, that will be flipping 1 over root 2, so that becomes root 2 over 1, which is just root 2. Secant of pi over 4, again, will be flipping root 2 over root 2, and that's just going to be a root 2 again. And then the cotangent, pi over 4, again, it's just be 1 over 1, which is just 1, right? So there goes your functions. What if theta is equal to pi over 6? This is a little bit more tricky. So if we have theta is equal to pi over 6, pi over 6, the other angle is pi over 3. And if we label these sides A, B, C, as per usual, what we want to do here is to do a little bit of, not just a trick, but something to help us to work it through better. Place two of these triangles together, and so we have a side C. A side C becomes an equilateral triangle. So C is equal to 2B, so B is equal to C over 2. And then we can find, using the Pythagorean theorem, A squared plus B squared is equal to C squared. I want to find A. We work it down to get A is equal to C root 3 over 2. Now let's find the sine of pi over 6. Pi over 6, right? So we know B was equal to C over 2, and A was equal to C radical 3 over 2, and then C would be just C. So that's going to be, sine would be B over C. So that would be C over 2 all over C. So that would be 1/2. The cosine, pi over 6, would be A over C, which would be C root 3 over 2 divided by C root 2 divided by C, and then that will become root 3 over 2, right? Tangent, pi over 6, be equal to B over A. So that would be C over 2 divided by C radical 3 over 2. So that will become simply just radical 3, right? Radical 3. Radical 3. The radical 3 will be in the denominator. There's going to be 1 over radical 3. Right? Or if you rationalize this, it becomes root 3 over 3. Right? That equals root 3 over 3. Okay, let's look at the reciprocal functions. Cosecant pi over 6 be 1 over 1/2, which should be equal to 2. Secant of pi over 6, pi over 6, equal to 1 over root 3 over 2, which should be equal to 2 over root 3. If you rationalize that, times root 3 over root 3, we end up with 2 root 3 over 3. And then, finally, cotan of pi over 6 would be 1 over root 3. Flip that, that simply becomes root 3. Right? So the cotan is root 3. Okay. Let's look at a different kind of example. Example 4. This example, suppose that the right triangle has legs, length 4 cm and 7 cm. Evaluate the 6 trig functions of the smaller acute angle. So we want to draw a triangle with 7 cm and 4 cm. The smaller acute angle, let's call it theta, is opposite to the side with 4. We do not know the hypotenuse, so let's quickly calculate the hypotenuse, and then let's work it. So the hypotenuse C will be equal to the square root of 4 squared plus 7 squared, and that will be equal to the square root of 16 plus 49, be equal to the square root of 65. Okay, so C is the square root of 65. So then let's do the sine theta equal to 4 over radical 65. If you rationalize that, that becomes 4 radical 65 over 65. Cosine of theta would be 7 over radical 65. Rationalize that, that becomes 7 radical 65 over 65. Tangent of theta, that is opposite over our hypotenuse, that's going to be 4 over 7. Let's look at the reciprocal functions. Cosecant theta, you put 1 divided by 4 over root 65, so that becomes root 65 over 4. Secant theta. Secant theta equal to 1 over 7 over root 65. That becomes root 65 over 7. And the cotangent of theta, cotan theta, will be the reciprocal of 4 over 7, which is equal to 7 over 4. And that is it. Okay, now let's try to do one more example.